Good morning, one and all. This video is about the water quality parameters and the permanent hardness, temporary hardness, and the quality of the water we are using day to day life, which is subjected to engineering chemistry syllabus. We are going to discuss here. So, what are all the salts generally present in the water? Okay, so how it deteriorates the water quality and whether it is applicable to the public domain in regular day-to-day life like that. So we know very well about hardness because of salts present in the water. It will reduce the original properties of water which is not able to use in day-to-day life. So such as salts will attributes to temporary or permanent hardness, which in turn we need some of the uh, techniques to remove those salts present in the day-to-day life that we are using the water. So such as salts are chlorides, sulfides, like that, etc. So first we see about chlorides. So chlorides are present in all water sources. Source of chlorine is from mineral deposits, domestic wastages, discharge of waters, industrial waste waters, irrigation drainage, human excreta, especially human beings' urine, okay, which contains this chloride. So, what would be the effects? So, and it will have undesirable taste. That is the significance. So, it's contribute to hardness in the water. In industrial wastes, it deposits and boiler corrosion will happen. So, these are some of the effects of chloride in water. Next one is iron. So, it presents, we know very well, from soil, rocks, and plant matter, etc. Even from pipes, even after rusting, we used to see the content of ions. This is also one of the form of corrosion we know very well, and from coagulants. So its effects would be stains in cloth, growth of iron bacteria in pipelines. That would say it is also a type of corrosion. Red water complaints like that. Corrosion of pipelines, taste and odor problems, etc. Yes, it is very well that sulfates present in the water as a calcium like that occurs in water from solvent action of water on gypsum, calcium sulfate, and other salt like that. Decomposition of organic matters, industrial wastewaters, especially in atmospheric SO2, which in turn creates a very dangerous pollution, acid rain to the atmosphere, and its effects, laxative effects, the problem in the human stomach like that, taste, scales in boilers. It means more number of salts would be settled on the inner part of the boilers. That is called hardness. That is called scales. Total dissolved solids, TDS. This also contributes to the salts present in the water. Important constituents are bicarbonates, chlorides, and sulfides of calcium, magnesium, and sodium. There is generally an increase in hardness with TDS, and its effects are the taste, laxative effects, indication of hardness, and waters with high total dissolved solids or TDS are not desirable for industries, even for not desirable for regular day-to-day life. So these are some of the important uh, problem in TDS presence. And of course nitrogen is important to all life, we know very well. And nitrogen in the atmosphere or in the soil can go through many complex chemical and biological changes. So nitrogen occurs in natural waters in various forms such as nitrates, NO3, nitrite, NO2, ammonia, and H3. The water used for domestic and industrial purpose should be free from toxic substances and pathogenic bacteria. So DO, it is a very important topic in regular water. Surface waters of good quality should contain dissolved oxygen. The optimum dissolved oxygen in natural water is 6 to 8 ppm, which is essential for supporting aquatic life. Otherwise, the aquatic life will get destroyed. There is a limit for even the skilled value of dissolved oxygen present in the water. A fall in dissolved oxygen level indicates that a water body is polluted with organic matter. The basic Brinker's method is used to determine the dissolved oxygen present in the water. So, thank you one and all.